Hi, I'm Ashley Smith, and welcome to Nature in the Hills. Today we'll be speaking with local astronomer Steve Hassel. Welcome to the show, Steve.
Thank you for having me.
Yeah. So first of all, what is astronomy for folks that might not know?
Astronomy, that's a big question to answer, but the best way I can put it is astronomy is the study of the universe and everything in it. Not only that, but how it all works together. Astronomy really draws on lots of different disciplines in science. It mostly draws on physics, but you're also drawing on chemistry, biology, geology, and the more that we discover about astronomy, the more we discover about the world around us.
Wow, very cool. So it's a very broad study, including lots of different disciplines.
Absolutely,
That's great.
absolutely.
So what first got you interested in observing the night sky?
Okay, this is a little embarrassing, but I'm not really sure. And I say that because a few years ago, many years ago now, my wife had a book from one of her old college courses. And it was just a basic astronomy course, and I was somewhat interested in it at that point. I don't know exactly what it was that got me into it, but I started reading that book and I started absorbing that information. And the more I read, the more hooked I got. And then I started grabbing whatever I could. I would go outside and just look up. I would grab binoculars. Finally I went to a garage sale, and for $40 somebody had a telescope. So from there it just kind of snowballed.
Yeah.
Yeah.
I think that's true for a lot of folks, not just with astronomy, but a lot of different sciences. Once they get a little taste of it, they just get hooked and want more.
Absolutely. And the thing for me is I see astronomy as kind of an oasis of sorts, in that, in the day-to-day, people around you, and even, myself included, you think you have all the answers. Somebody asks you a question, and oh no, you're wrong. But what's cool about astronomy is that it reminds us of how much we don't know. You look up at the night sky, and you know a lot about your immediate surroundings, but you look up and you look at the vastness of the universe, and you are just blown away by all this stuff that you see all the time. And a lot of it, even scientists right now still can't explain. And to me, that is just absolutely the most alluring thing about it.
Yeah, absolutely.
Yeah.
So how does astronomy affect the everyday person? Why would it be important to them?
I would say the most important thing is that it keeps people dreaming. It keeps people, it's what makes kids want to be astronauts. It makes people want to answer questions and achieve things that somewhat are generally perceived as impossible. It really kind of helps us gain perspective of where we are in the universe, and not only that, but our days, our months, our years are all based on astronomy. Ancient astronomers, they came up with the system of dates that we have right now, because they needed to plant food. They needed to know when the summer months were coming and the winter months were coming, more importantly.
And I think that's one of the things that people forget, why astronomy was so important to us as humans.
Yes.
I mean, we really look to it as when to plant our crops, how to tell time, how to tell when the seasons were changing.
Absolutely. It is. It's the basis for our measurement of time, our measurement of the seasons, our measurement of the days, the weeks, the months, the years.
How to find our way, too.
How to find our way. And, if we didn't know all that, we wouldn't have planted crops. And if we didn't plant crops, we may have disappeared. We might not be here right now if it weren't for astronomy. So go astronomy.
Go astronomy.
Yeah. And like you said, navigation, too, was a big thing. Before we had GPS. GPS even itself owes a lot of its history to astronomy.
Right. People kind of forget all those satellites up there guiding our way for GPS units.
Exactly.
It's kind of like magic.
Right.
So what are some tools of the trade for folks that want to get started in astronomy, if they've just got a little taste of it and they want to take off running with it like you did? What are some tools of the trade to kind of get started?
They need their eyeballs. They need some bug spray. They need a comfortable lawn chair.
Right.
And they need, there are a couple of things. You don't necessarily need a star map, but having some sort of a tool, even a computer, to kind of familiarize yourself with the nighttime sky. My favorite tool is this thing here. Hopefully the glare isn't too bad. It's called a planisphere, and basically what it does is a planisphere, and for your latitude, it shows you what is going to be in the nighttime sky at any time of the year for any time of the day, or really, after the sun's gone down. It doesn't really matter. So something like this really helps somebody get familiar with the sky.
Right.
So that's where people who are getting started, that's where they should begin. They should really begin there. Now, if you already have things, that's great. But a pair of binoculars, for example, is great for looking at star clusters, for example, that you can't normally see with the naked eye. It's great for looking at binoculars are great for looking at the moon. They're great for looking at planets. Again, bringing out detail that the naked eye just simply can't resolve.
Right. I think a lot of people associate binoculars with the daytime sky watching. They don't really think
Right.
that they're suitable for nighttime sky watching.
Right. As a matter of fact, there are amateur astronomers out there who do nothing but binocular, and they
Right.
buy really nice, really expensive binoculars. They'll even have their binoculars on mounts, and it's really fantastic, and it's really easy setup and tear down. You don't have to worry about a big bulky telescope. So I recommend at least just getting a pair of binoculars. If you want equipment, get a decent pair of binoculars. But there's really nothing that's going to allow you to take in the majesty of a true dark sky, seeing the bands of the Milky Way, and maybe even taking in a meteor shower. You can't do that with any optics, really, because you don't have that depth. So your eyes, some simple tools like star maps, binoculars, and of course there's telescopes. Telescopes for people starting out, we're talking about beginners. I would not recommend a beginner dive into a telescope. There's just too much to it right at the outset. You should start with your eyes and a pair of binoculars and see if it's right for you.
Right.
If it's right for you, then you can start looking at telescopes, but you want to research them.
Right.
And we'll talk a little bit more about
And they can be pretty
telescopes later.
expensive, so you want to make sure that you buy the one that's right for you.
Basically, a telescope is like, hey, how much you got? Seriously, you can go either way. You can spend too little on a telescope, and you'll have something that does not do what you expected it to do, and you'll never use it. Or you can spend a lot of money on a telescope, which requires hours of setup, and you'll never use it.
Right.
So you have to, know what you're doing. Are you observing? Are you taking pictures? How heavy is it? How, are you willing to stay outside with it? You can't just leave it outside, obviously,
Right.
Somebody might think it's nice and take it. So there's a lot to consider with a telescope. Now, that said, if a beginner says, no, I want a telescope, say, fine. I would point them personally in the direction of what's called a Dobsonian telescope. I do not own one personally, but they are fantastic for beginners. They are a large mirrored reflector telescope, which takes the light from the stars and reflects it back to your eye. They really offer you a lot of bang for your buck. They're still a couple $100.
Right.
But they're not motorized. All they are is a tube with a mirror and an eyepiece. But they're very portable. They sit on the ground like on a swivel, like a Lazy Susan type swivel. Being so affordable and being so portable, a lot of people find them very, very helpful.
Right.
But you really need to know your sky, because you say, okay, now I want to see a galaxy. Well, you got to know where that
Yeah.
galaxy is,
Know where to
and
look.
you need a dark enough sky. So there's a lot that goes into it.
Right, more than just a telescope.
More than
so
just a
it's nice
telescope.
to know that one doesn't need to have a telescope to observe the night sky and to
Right.
start getting interested in astronomy. But I
Absolutely.
think it's important for folks to know how a telescope works and to learn the basic parts.
Yes.
So let's take a second and kind of go check out a telescope and see how they work.
Ooh, okay.
So around us here are some tools of the trade that we mentioned before. One of the things we talked about were binoculars.
Right.
So these are a simple pair of binoculars, but you can spend upwards of hundreds of dollars on more advanced binoculars.
Oh, yeah.
But even getting started with a pair like these is excellent.
Yes.
Also, I found that bringing a field guide out with you also helps, especially for a novice that might not know a lot about the night sky.
Right,
This
right.
Peterson First pocket field guide kind of gives you some more information about the planets as well as constellations, where to find them, some different star maps. So this is also something good to bring out with you.
Yeah, absolutely.
And in front of us here, it's a basic telescope. So Steve, why don't we go through some of the parts and maybe their functions for people that might not know.
Sure. We're going to start with is the front of the telescope, because this is where the light comes in. The light from a star or a planet, whatever you're looking at, comes in through this this front tube and it hits the lens up front, which is known as the objective. And the objective on this refractor telescope is a piece of curved glass that once the light hits it, it begins to focus, and it runs down this empty tube here. It's just absolutely empty inside. There's no special equipment inside here. And it focuses down to a point. Once it gets down to a point, it enters what's called the focuser tube, and it's called that because this is what you use. By turning these knobs, you can lengthen the path that the light has to travel in order to find that sweet spot where the light's going to focus. Once you find that sweet spot, you'll actually before that you'll have an eyepiece in here, which is a small lens itself, curved lens that then allows you to view the object that you're looking at in the telescope. So and generally, what happens is, depending on what you're looking at, you'll have to choose the right kind of eyepiece. The right kind of eyepiece, if you want to see an object large, you will use a high-powered eyepiece. We generally don't look at magnification. A lot of people will ask me, well, what, how much does it magnify? And I say, I really don't know, because when you magnify something, you lose light, you lose detail. What you really want to focus on is the brightness of the object. So if that means the object has to be smaller, but you see more detail, that's more important. So typically, though, if you want to see a larger swath of the sky, you would use a lower power eyepiece. And what that's going to do is that's going to allow you, if you're looking at a star cluster, for example, you want to get as much of that into the shot as possible. So you would use a lower magnification. If you're looking at Jupiter or the moons of Jupiter, you can get away with a higher eyepiece. And what that will do is that will allow you to see things on a larger scale, but you are going to get less detail. And also, when you're at a higher power, things tend to move, just like the sun moves across the sky, these objects move across the sky too. So they're going to move through your field of view pretty quickly, the higher magnification you have.
Mm-hmm. Just like when you have binoculars and you're using them for bird watching,
right.
If you have that, if it's going to zoom in really close on them, it's more difficult to find the bird in the tree or see more birds than just one.
Yeah,
so it's really similar to
that's
that.
actually a good point. It's always a good idea to have multiple eyepieces to find the object first, because you want a larger picture of the sky, and then once you find it, you center it, swap out eyepieces, and then you can get a really good look at it. Cool. It's very hard to find things when you're looking at a tiny portion of the sky. One other thing here is you have a smaller telescope on here, which is basically the same thing as this. It's a refractor telescope. This is called a finder scope. And what this does, this is a very low power telescope, which does exactly what we talked about with the eyepiece. It shows you a very large portion of the sky and kind of points your telescope in the general direction of what you want to look at. Once you've found the object in the finder scope, which isn't really much to look at, then you fine-tune it by looking at it through the eyepiece, and then you can get a really, really good image.
Very cool.
Yeah.
So Steve, let's talk about your personal telescope, which I think can be a little bit intimidating to people, but you can show us the parts and their function too.
Sure. I'm just going to slip over here. This is known as a Newtonian Reflector telescope. What this does is, instead of, we talked about the refractor a little bit, and it uses a piece of glass up front to focus the light. This uses a mirror. The mirror is located this is the back of the telescope. It's located at the back of the telescope, so the light will come in through here. Again, it's just an empty tube, really not much to it, and it hits this curved mirror. Now this curved mirror, the light is going straight until it hits the mirror. The curve of the mirror then begins to focus the light all the way up, and then what it does is there's a secondary mirror in the front that then reflects that focus light down towards this focuser tube here. And again, this is what holds the eyepiece. So essentially, it really performs the same. They perform the same functions, just in two different ways.
Okay.
I use this one primarily. I prefer this for imaging and observing. I do both. Obviously I like to bring it out to the campout so people can look in it. It's got a large mirror. It collects a lot of light, but it also does a fairly good job for imaging. Generally, if you're just doing imaging, you would want a refractor. It gives you sometimes sharper images, but I like to balance the two, and I find that this fits the bill quite nicely. So really, the main difference is in the objective. Once the light hits the telescope, how does it begin to focus it? And you have various problems with different scopes depending on what you're looking at or what you're using. With a refractor, once it starts to focus the light, wavelengths bend at different rates. So you have something in here called aberration, where you're looking at an image and it looks like, oh, it's cool, but it's got a little green or a little red around the outside. So while certain wavelengths are focused, other ones might be out of
Right.
out of focus a
Right.
little bit. So that's all fine and dandy. You don't get that with a Newtonian reflector, but what you do get is you can get some odd shapes, if you're not perfectly aligned. So it's a trade-off. But the biggest difference here is you can probably see the mounts.
Right.
The mount is, some people say the mount is sometimes even more important than the telescope. And in many ways that's true. Now I'm looking at the mount here, and this is called an alt-azimuth mount. It moves side to side and up and down, and that's it. And it's great for just observing, for pointing at something and looking at it, and you can slowly move it as the object moves. The mount itself is not very complex, but it allows people to do what they need to do. But the other important aspect is the actual tripod that the mount is sitting on. This is a wooden tripod, and wooden tripods tend to do better with absorbing any vibrations. Thank you. That's what I was looking for. And a lot of times, if you buy like a cheap telescope, you'll get like plastic legs or just some steel tubes, and those things. If you get a little gust of wind, the image just shakes around like crazy. So wooden mounts are fantastic.
Great.
This is a little bit different. This is actually an aluminum mount. It also does a very good job at absorbing vibrations. But it's a wooden a wooden mount won't support as much weight as an aluminum frame. Aluminum frame is a little stronger. So as you can see, the difference in the mounts are quite extreme. So let's talk a little bit about the mount. What we have here is these two big donuts here are called counterweights, and what they do is they counteract the weight of the telescope. The telescope's pretty heavy, so what happens is when this telescope is moving like this around, you want it to be balanced because the mount that it sits on is actually motorized. There are motors in there that are constantly moving, compensating for the rotation of the Earth. So if you're looking at an object over the course of the night, this thing's going to move and keep the object in focus. So the motors that do that would take a lot of stress if they only have the weight of the telescope on one side. So this counterweight balances it all out. It adds more weight going down, but the motion moving sideways is nice and smooth. And that's this type of mount is called an equatorial mount, and an equatorial mount does just that. It compensates for the rotation of the Earth, whereas a mount like this will not. You have to move it around a little bit. So you'll probably also notice I got a couple more scopes on here. 'Cause one isn't enough. So what we've got here is this also is a small refractor scope. It works just like this one here. But what I use this one for, and you could use this just for observing if you'd like to. In fact, we do a lot of lunar observing through this one. It's good for looking at the moon because it's not real bright. What I use this for is when I'm imaging, I stick a second camera in here. That second camera will look at the object that I want to image or take pictures of with this scope and sends those signals to the computer down here. And then the computer will then tell the scope where to go. So that way I can maintain precise control of what it is I'm taking an image of. And again, we have the finder scope. We have a finder scope here. It serves the same purpose. When I'm first setting up, I use the finder scope to find my object in the sky. I find that once I find the object, then I basically do a reverse order. I find it here, I center it, I lock it down. I find it here, I center it, I lock it down. I find it here, I center it, I lock it down. That way, all of the scopes are looking at the same thing at the same time.
So it takes some time to find what you want to look at in the night sky.
Yeah,
it goes back to that being patient thing.
It does, and when you have a bigger scope, you get better images, you get more detail, but you also there's a lot more responsibility into going into setting it up. There's a lot more work in setting it up. And sometimes that's one of the reasons I don't recommend people just jumping in and saying, hey, I'm going to spend $5,000, I'm going to buy as much scope as I can. That's the worst mistake you can make. Because first of all, you have to know what it is you want. If you want to do observational astronomy, what I would recommend doing is getting into a Newtonian reflector, but maybe buying one of those, the Dobsonian telescope, which unfortunately we don't have an example of here. But it's like this. In fact, it's precisely this tube, but it's on the ground and it's on like a Lazy Susan. It's actually a combination of this telescope, this mount, but instead of having the tripod, it's on a Lazy Susan. So a Dobsonian will work like this, sitting on the ground, and you can move it around the sky. And for $200, $300, you can get a scope, sometimes it's twice as big as this one. And you can see a lot of things. You can't take pictures with it, but. All right, one thing that I want to mention, and this is labeled on any telescope that you buy, even some binoculars, is you never, ever, ever, ever under any circumstance want to point an open telescope towards the sun. That's the fastest way to go blind. There are people who have gone blind almost instantly by doing that because it's focusing the full power of the sun into an eyepiece. Think of when you would burn leaves when you were a kid with a magnifying glass. It does that, but to your eyeball. And don't find out the hard way. There are disclaimers all over the telescopes. In fact, mine's got one on the other side, of course, from the cameras, but it's a little sticker that says never pointed at the sun. Now, that said, you can look at the sun with these. How? There are filters that you can buy. There are filters that you can put on the ends of the telescope, one here, and they're generally made out of mylar, or there are glass ones that you can buy. And what that does is that reduces the incoming light by about over 99%, which is enough to bring down the brightness of the sun. You can see sunspots, so you can do solar observing with these. You just have to be very, very careful that you've got that filter on, and because you're going to find out very, very quickly how horrible they could be, So it's just very important.
That's great.
Yeah.
So this is good information for folks that just want to get started, like we mentioned before, with binoculars and a field guide or just the naked eye, and then moving up from a more basic telescope to a more advanced one.
Right.
Yeah. Thanks for walking us through that.
Absolutely.
So some folks want to observe the night sky maybe indoors or in a larger way. So where's the closest large observatory that folks can go to?
I would recommend looking into the Cranbrook. They have an observatory there that they do research, but they also they have open observing nights where the public can come in. Basically, it's called public observing. And they can come in, they can look at the telescope. In fact, it's a very large, old-fashioned refractor telescope, and I think they may have actually upgraded the facility, so it might be a lot cooler now than what I remember.
So maybe if you were there a few years back, it's something to check out again.
Absolutely, I was there a few years ago, and they had a real large, very old. It was a very long refractor telescope, and it was neat to see how it all worked.
Does it take in a lot of the night sky? Are you able to see a lot of images that way, going to an observatory versus maybe going to a stargazing party where there's smaller telescopes?
Well, the amount of sky that you see really depends on the eyepiece that you put in there. So when you're at Cranbrook, if they're observing, we were observing Jupiter at the time. So they put in a higher power eyepiece. You see a smaller swath of the sky, but you see your image a little larger. It's a little dimmer because it has to spread that light out. But if they're looking at star clusters or if they want to look at a larger swath of the sky, they'll put in a lower power eyepiece. And that's really neat because they'll come in, they have the cool music playing, it's all red light, and you walk in, you walk up on the platform, everybody gets a turn. They'll have an astronomer there. You can see all the computers that they use to gather their images. And like I said, I think they've recently upgraded, so I got to get myself there too and see what they've done. I would highly recommend Cranbrook.
Definitely go check it out. Great. So how do you think that technology, I know we talked about telescopes, but how do you think other types of technology has changed astronomy, made it better or even made it a little bit more difficult?
Well, I would say technology has not changed astronomy, it's absolutely transformed it. And I say that because, it used to be, but before there were telescopes, you would go out in the sky and you would ponder and you would write things down and you would mark positions of celestial objects, even if you didn't really know what they were. Then along came telescopes, but even then, you had to sit out there in the cold, 4 hours, watching things, writing things down, and all the way up through the early 1900s. That's how it was done, and then we started. Even later than that. Once computers really started to become prevalent, that has really transformed it. Now you can operate telescopes over the internet from the other side of the planet.
Yeah.
You can operate robotic telescopes, which can survey the sky, hundreds of objects every single night. Just look at them, measure them, move on to the next object, and all that, you don't have to write down anything. It all goes into a database. And then the next day, the astronomer goes through the data and starts going through it. So it's really changed how the astronomers collect their data. It is very rare now for a research astronomer to ever look through an eyepiece. They have data collectors now. Where the eyepiece would go, basically they stick a camera. The camera collects the light, goes into a database, it gets analyzed, and that's how the astronomers make a lot of their big discoveries.
It's kind of sad that they don't take more time to observe the night sky. I mean, it's amazing that the computers are doing so much work and collecting so much data, and we've learned way more than we ever thought possible. But
well, it's kind of a two-way street. I mean, it's made it a lot better in that the discoveries we're making now are just so profound and so much more than anyone ever could have thought. But yeah, it does take that human element out of it, and that's why astronomy is really split off now into observational and then research or imaging.
Right, almost
astronomy.
two different fields.
Right, and I get more pleasure out of observational when I can share it with people.
Right.
So.
Yeah. So that being said, too, you like sharing astronomy with folks. What are some of your favorite spots to observe the night sky, and then recommendations for folks just getting started? Some cool spots they can go check out.
My favorite spot is the most open, darkest field I can get to. That doesn't necessarily have to be 50 miles out of town. Of course, if you can get there, great. But I find if you can get away from immediate light, like parking lot lighting,
like different types of light pollution.
Lights on that, yeah, light pollution. If you can get away from that, if you can get away from tall trees and buildings too, so you can have a larger swath of the sky to look at. The problem with lighting in the immediate areas, you get something. It's not just light pollution; it's called light trespass. And what happens is, if you can see a light in your peripheral vision, what happens is that light can probably get into the eyepiece and, render a little spot in there, and you can not see anything. It gets very frustrating very quickly. Light pollution also is a problem, but for most things that an everyday backyard astronomer would want to see, if you can, do those three things: get to an open field, get away from lights, and get away from tall structures, you are basically going to find a favorite spot pretty quick.
A good spot.
Yeah.
Do you find that sky watching, is there some good areas in Heritage Park that you've checked out before to observe the night sky?
Actually, at the great Farmington Hills Campout, there's a lot of great spots to set up. Really anywhere. You just don't want to be too close to the campers, and you don't want to be too close to the fire pit, for obvious reasons. But yeah, really anywhere in this park offers great views of the night sky.
Right, and so obviously it's hard because the Heritage Park closes at dusk or when the sun goes down, but there are some opportunities, like you mentioned before, at the Great Farmington Hills Campout that you might have a chance to come and observe the night sky.
Yeah.
So you have been to the Campout
Yes.
the past couple years. It takes place in June. Tell us a little bit about that and kind of what made you want to bring your telescope and get started with that, and how did you share it with people?
We were 2 years ago, we came to the camp out, and my kids were playing in the water park, having a lot of fun, and I was sitting there, and we weren't actually going to camp. We were just going to stay as long as we could so the kids could have fun, and then we were going to go home. And I looked up and I saw the sky. There wasn't a cloud in the sky, and I checked my phone. It's going to be clear tonight. I'm like, hey, I got me one of them fancy telescopes. So I ran home, and I came back with it, and I left it in my car. And as it started getting dark, I just walked to my car. Nobody knew me from Adam. And I just picked a spot and set it up. And I thought, one of two things will happen. Either I will get kicked out, like say, you don't have permission,
No
get out
way.
of here. That's our moon, you can't look at it. Or, the campers are going to be in for a real treat. And luckily, the second thing happened. I've been to star parties before. I've been to public outreach events before, and it's just amazing. You set up the telescope, and you get a line like that. You get people who want to see stuff. And that's the real payoff. And that's what happened at the Farmington Hills Campout, especially with kids. I mean, the kids just came from the campsites, the parents, and I had a line before I knew it. And so that was really, really great. And then I think last year we actually camped out. So I was able to keep the telescope open for longer.
Right.
So.
I think it had a huge impact on not only kids, but also adults. I mean, I know after the camp out, we had a few families stop into the Nature Center and ask, who is that guy with the telescope? And is he going to do programs at the Nature Center? So, and I think some folks even kind of looked forward, hoping that you'd be there again this last year, and probably again this summer too.
Yeah.
So I think it had a huge impact on people.
Well, I plan on being, schedules are what they are, but I plan on showing up. So just a little away from the fire pit. Right. Look for the scope. If you see a crazy guy setting up a structure, that's me.
Wonderful. Well, it's kind of cool how you mentioned too. You're kind of looking at the night sky, and all of a sudden it clicked like this is a perfect night to sky watch.
Right.
So, what are some really great times to observe the night sky? Whether it be time of night or also time of year, are there better times of year over others?
Oh yeah. Right now is not a great time of year. Right now, it being February 1st, generally in the winter months you get a lot of clouds. You get more clouds than anything else. So that puts the kibosh on it right there. It's in astronomy, or astronomers, when they have a cloudy night, they hit the books, they do the research, they do some reading, but generally here in the Midwest in the wintertime, lots of clouds. Now, you do get clear nights. The problem with that is on a clear night, it gets really cold. And when it gets really cold, people don't want to be out in that, no matter how nice the sky is. I mean, it's very clear in the winter, too. You don't have a lot of turbulence in the sky bouncing the stars around. But sometimes it just gets so cold that they can't handle it. And it's also very hard on the equipment. Now, there is equipment out there that you can, if you want to spend a couple grand more, you can get stuff that can withstand that. Mine personally cannot, and nor can my fingers. I would say the best time of year is between mid-May and early November. That's when I have had the most luck. Obviously, at the Campout, and the Starry Night program, we do that during the summer. There's a much higher chance of it being clear. Right.
Plus, you can stay outside a little longer. It's warmer out there.
Yeah, you can stay outside longer, and a lot of people think, well, it doesn't get dark till later. It's just like, that doesn't matter. You want to see Saturn, you want to see the craters on the moon, you just need to get the sun out of the way. Once that sun's below the horizon, we can start. If you want to see galaxies, that's tough to do even on a dark sky site without cameras and time exposures. But if you just want to see the rings of Saturn, the moons of Jupiter, the craters on the moon, even some globular clusters, which are really amazing, you don't need a completely dark sky for that.
Okay.
So the time of night depends on the time of year. But during the summer, as soon as that sun's out of the way, let's get rolling.
Right.
Yeah.
Great. So what are some of the most interesting things that you found, or some of your favorite things that you found during your time of studying astronomy?
The most interesting things I've found, the most interesting things that I've observed would be, Saturn for sure. That's hands down. When you look at it through a telescope, it doesn't look like it looks in the textbooks. In the textbooks, it's big. You see all the rings, and you see all the divisions, and all the the little lines in the rings. Through my telescope, you don't see that. Through a larger telescope, you would. But still, when you see that for the first time with your own eyes, your jaw hits the ground. And so does the people that you're showing. People say, they look at it and they say, well, it's amazing. Now, it's a little small. But still, it doesn't matter. It's absolutely amazing. Same thing with Jupiter. You look through the telescope and you see the bands on Jupiter, and you know that, first of all, you can fit, there's the red spot on Jupiter, which sometimes you can see, sometimes you can't. You can fit Earth inside that thing. And then the bands that go around Jupiter, they're massive storms that are happening. And you're looking at that and you're thinking what that actually is, and it really sends your mind kind of in a spin. And you can also see moons orbiting it. If you look at it at different times of the night, you can actually see the moons move, which is a really cool thing.
Right.
And then at real dark sky sites, you can actually see galaxies. You can't really make out the detail through your eye. Your eye just isn't fast enough. Your eye just doesn't work that way. but still, it's pretty amazing.
So those couple things that you've mentioned, do you have a favorite thing that you like to observe? Something that you might go to every time you observe the night sky, or something that you like to check out at least once when you're...
Yeah, the planets, for sure. Whatever's in the sky, whatever the planet of the night is. Typically, right now it's Jupiter. If I took the telescope out there, I'd go right to Jupiter, and I'd look at it. I'd look at its moons. And if I had anybody with me, I would say, hey, we're looking at Jupiter right now. And I would also look at globular clusters, which are ancient star clusters that ride outside of our galaxy, and some astronomers believe that they're even older than the galaxy. So that's really neat.
Yeah.
And I'll show people that. They just look like a faint, fuzzy patch. You can't really make out the stars. But again, once you know what you're looking at, it takes on a whole new meaning.
Right.
So
Very cool.
that's what I go for.
Very cool.
Yeah.
So we talked about how you helped out at the Great Farmington Hills Campout in June, but you've also been a really helpful volunteer astronomer for us here at the Nature Center, helping with multiple programs. Another program that we do in March called One Starry Night, you've helped with that in the past, and that's kind of a unique event in that it is structured around what's called Earth Hour. And Earth Hour is where everyone is supposed to turn off all of their lights, all of their electronic devices for 1 hour to conserve energy, and it's kind of a
Help
message.
the astronomers.
Right,
Darken the sky,
darken the sky, cut down on all that light pollution.
Yeah.
So we do that event based around Earth Hour, and for that second hour of the program, we pretty much go outside in the dark and observe the night sky.
Yeah.
So can you tell us a little bit about what you did at that event and what you thought of the event?
Well, at that event, I basically supplied my telescope for, after the activities inside were done, we went outside. There were lots of activities happening, but we opened the scope up for an open observing session, much like we did at the park. And, again, boom, the lines form.
Yeah.
And
We had a lot of people there too.
there's a lot of people, and that's fine. I mean, those lines get long, but people move through pretty quick. And what's amazing is that people go through. If the line doesn't get any shorter, and you see people come through 2 and 3, 4 times, and so to me that's the most rewarding thing. And then people see everything, and then you turn to another object, boom, that line's back. They want to see this now. So that's really was my role last time. Moving forward, I'd like to have more of a hand in maybe some of the inside events as well.
Right, because at that event, how it normally works is we do some things inside and show folks some different things that they can observe in the night sky. One of those things being constellations.
Yeah.
So do you find yourself looking at constellations and trying to figure out how they came to be and how people saw those different shapes in the night sky? Because I think that's one of the things, especially kids, they have great imaginations and they can kind of discover those things.
Right.
But I think sometimes us as adults looking at some of those constellations, where did those come from?
Right. Now, this kind of goes back to your question about technology. What are some of the negative impacts of technology? One of the negative impacts of my telescope is motorized. It's computerized. I wouldn't go so far as to call it robotic, but it is computerized, and it does not require me to know all the constellations in the sky, which is kind of sad. I should know them better. But that said, I think it's really important for for kids and anybody who's looking at the night sky to at least become familiar with the constellations.
Right. Especially the more common ones that are more easily identifiable.
Yeah, right. And and I do have to know some, because a lot of the targets I go for example, the Andromeda Galaxy. I know right where in the sky to look for it, because I know it's surrounding constellations. Cassiopeia points at it, and it's right, and then I basically follow it, and I find the Andromeda constellation, and boop, there it is every single time. So I do need to know some, but I definitely need to get more acquainted myself. So,
right.
I'm guilty of that.
It's something fun too during the One Starry Night program, and we kind of take some time to learn some of the legends of the constellations,
Right.
which I feel like can be really interesting and fun to discover where they came from and the story behind them. So that's kind of what we do for the program in that beginning part, learning about the different things to see in the night sky, and then we get to go out there and actually find some of those items, which is even better. Yeah,
and there's so much lore attached to those constellations too. I mean, they're very important in human history.
Right.
A lot of stories. Not only are there stories attached to them, but if you bounce from culture to culture, the stories change a little bit. Sometimes the names change, and that's very, very interesting. But for nothing else, if you want to go out and look at the night sky and find things, the constellations basically are your roadmap to find them.
Absolutely.
So it's very important to know them.
Right, and their constellations can be your roadmap in more ways than one. I mean, like we talked about earlier, they helped different explorers find their way across vast oceans and
Yes.
lands that they had never been before.
Right.
So not only are they your roadmap in the night sky, but they're also your roadmap when you're finding your way or trying to discover what time of year it is. Different
Exactly.
constellations are up during different
Yeah.
times of the year. So I think they have a lot of importance that people might not even realize.
Right. They're still important for that way. If you're
Right.
lost in the woods, you got nothing. If you can find the North Star,
Absolutely.
Polaris is what is the name of the star, then you know where north is. Then if you know where north is, you know where the rest of the directions are.
Right.
So that is still to this very day, what do they call it? Celestial navigation.
Yeah.
Is still relevant today.
Absolutely. So for folks that want to get started with astronomy, coming to a couple of our programs that we mentioned before, the Great Farmington Hills Campout, One Starry Night. We also do sky watching after some of our night hikes, full moon Fridays that we host in the summertime, different night hikes throughout the year.
Right.
If there are clear skies, we do some sky watching afterwards.
Yeah.
But what are some different clubs or organizations that you might be a part of? I know you mentioned star parties earlier that we
Right.
talked about. What are some different organizations that new astronomers might be able to be a part of?
Well, there are two that come to mind. I used to be a member of the Ford Amateur Astronomy Club, the FAAC, and that was a lot of fun because not just their mission, but the mission of just about any astronomical society is to get the word out, to get people engaged
Right.
in the night sky. So they do a lot of public outreach events. And
That's
that's where the star parties that I was able to participate in were through this astronomy club. They would just set things up. They would just like send emails to people saying, hey, you guys are having an event. It's going to be dark. Can we bring our scopes and show off the night sky? And 9 times out of 10, they say, heck yeah, bring them. But they're also open to really anybody who wants to join. You don't have to have a telescope. If you are interested in astronomy, you don't know where to go, join one of these clubs. There's like a yearly dues.
Right.
I think for the Ford at the time it was like $35
Yeah,
for the
usually
year.
they're not too bad.
No, not at all.
And then you get to go use other people's telescopes.
Yeah, well, a lot of these clubs will actually have telescopes
Right.
for you to use. You can even take them home for a week or a couple of weeks to familiarize yourself with them. So they're very, very interested in getting people educated about it. And not only that, but once you join the club, you start networking with people who share your passion.
Right.
And you form friendships, and you start to bond a little bit, and it's really cool. Now just because of my schedule, I had to stop being a member for a while, but I will be a member again.
Right.
So there's the Ford Astronomy Club. There's also the Warren Astronomical Society, another great club, and there are lots of clubs.
Right.
You don't have to go very far on Google to find one
Right.
near you.
I know Seven Ponds also has
Yes.
some type of organization, and they host stargazing parties and things like that too. And those are all fairly local, which is nice. So I think if just doing a little research and finding your local organization or club
Yeah.
is probably the best way to get started.
Yeah.
Also, what are some websites or other resources that beginners can use to learn more about astronomy, or tips that you might have for them?
Right. I would go to the websites of these astronomy clubs first and foremost, because they are going to then be able to link you out to very relevant, up-to-date information for the beginner. As someone who's a little more advanced, I'm not going to say I'm really advanced, but I'm a bit more advanced, and also long-standing members of those clubs. There are other websites, but I wouldn't necessarily recommend a beginner to go to, because it's a lot of information.
Right.
You have to know what you're looking for. Another thing that I want to mention is in the tools of the trade, there are telescopes, binoculars, the planispheres, but there's a software program out there. It's free. It's called Stellarium. It's one of the best things ever. Basically, it's a planetarium program for your computer. It's open source, absolutely free to download, absolutely free to update. And I actually use this a lot to select my targets for the night. If I'm doing astro imaging, I will spend some time while the sun's still up. You can forward to the time of night you think you're going to be ready and see what's going to be in the sky. How close is it going to be to the meridian? Is it going to be, how high in the sky is it going to be? So I'll use that to set my time, and I'll use, and also pick the object that I'm going to image that night.
Right.
And it's fantastic. And it's fun just to go in and just kind of tool around the night
Look
sky.
around at all the cool stuff.
You can go thousands of years in the future. You can go
Wow.
thousands of years in the back with pretty good accuracy.
Wow.
So
Well, it's cool to know that someone like you that maybe is a little bit more of an advanced astronomer would use that resource.
Yeah.
But then it's also suitable for someone that's
Yeah.
just beginning to kind of look around to see actually what's out there
Yeah.
and what they can find in the night sky and how to get started.
right, and it's very easy to use. So that's the one program I would recommend to everybody. So
Any other last minute tips for people just getting started with astronomy?
be patient, honestly.
Right.
A lot of people, when they get started, the first thing they think is, I'm going to buy me a telescope. And a lot of times that's the biggest mistake they can do.
Okay.
They need to know, what it is they like about astronomy. Do they just want to go out and be able to name the constellations? You don't need any equipment for that. You need a passion for the night sky. But if you want to start taking pictures, or if you just want to observe objects floating in the sky, you'll need some sort of a equipment. But start light. Start with binoculars. And then if that becomes not enough, start looking into telescopes, but take the time to do the research. Buy the right equipment for where you are, how long you want to be outside, and what you want to do.
Great.
So.
Those are really good pieces of advice. I think
Yeah.
especially the being patient part.
Right, that could have saved me a lot of money and
Yeah.
headache if I'd followed that. But
Great. Well, thank you so much for coming on today and
Absolutely.
sharing all of your expertise about astronomy with us.
yes, yeah, absolutely.
Thank you. Thanks for watching Nature in the Hills.